In this lecture, we'll study the hole command. With this tool, we can design many kinds of industry standard holes, including counterbore holes, countersunk holes, simple threaded holes, etc., all conforming to relative thread standards. So in previous lectures, we've learned to create holes using the extrude command. I'll give an example here. If I right-click, create sketch, circle, just draw in a circle there, solid, extrude, select that circle. We've previously learned to make holes by extruding like so. Pressing OK, we have a hole there. So in this lecture, we're going to explore the hole tool and what additional options that gives us. So I'll right-click on that feature and delete that. And then we'll come up to create. And if we look here, we have the hole feature, which is a shortcut H on the keyboard. So I'll hit H on the keyboard, and then our toolbox pops up. The very first thing we need to define is the placement. So whether it's a single point, so i.e. a single hole, or whether it's multiple points. So we'll cover that shortly afterwards. But for now, let's focus on a single point. So I'll select this, and then we need to define a face. So in this case, I'm going to select this face here, I'll left click once. Now, as we can see by the preview, in the location that I clicked, a hole has appeared. I'm going to look at this from the top view. So this is not a fixed position, and we can move this as we want. So with the circle here, hold down the left mouse button, we can move that to any position we want. And if we see in the center there, there is a snapping point, which is the center of, in this case, a two-dimensional square that we're looking at. So we can snap on there, but let's say that we wanted this in an exact location relative to these two lines here. What we can do in our toolbox is use the two references. So the first reference, let's click select. I'm going to use this edge here as my first reference. Let's say 30 mil. And then I've got the option to add a second reference. So select that. I'm going to use this vertical line here. And again, let's go for 30 mil. And then we can position this hole exactly where we want it. So after we've placed our hole and we've determined its exact position, we then come on to shape settings. So first of all, we've got extents. So just like when we extrude, we can do a distance, which we set manually. We can do to, like to an object or a face, or we can do all. So all geometry in the way of where this hole is. So if I click all for now, you'll see it extends all the way down and the preview shows us the hole going all the way through. We then need to define the hole type. We've got simple, counterbore, or countersunk. For this example, let's go with counterbore, and then we need to define the tap type. So whether it's a simple hole, i.e. there's no thread, whether it's a clearance hole, a tapped hole, or a taper tapped. So let's just keep it simple and go with a simple hole, and then we need to define the dimensions relating to this counterbore simple hole. So in terms of the height, okay, that's our very first parameter. Because we've selected the extents to be all, that will remain as all. And we can change that by, if we go into distance, we can then say, I don't know, let's say a 25 mil hole. We'll see the preview change there. I'm going to leave that as all for the time being. And then we need to define the diameter of the counterbore, the height of the counterbore, and then the diameter of the hole. And we can also do this manually as well. So we have this arrow and these two sets of arrows as well. So this arrow here would determine the depth of the counterbore, this would determine the diameter, and then this one here determines the diameter of the hole. So we can adjust those manually, but in the case of holes, I would always recommend to do them using the parameters here and get the exact dimensions that you're seeking. So as an example, for the diameter of the counterbore, let's go 50 mil. The height of it, let's go 15. And for the diameter of the hole, let's go for 30 mil. Okay, let's press OK. And there we have our counterbore hole. Now just look at that from a section analysis. We'll see that a bit better. Okay. There we go. That's our hole there. So we could also do this using the extrude tool, but it would be many different extrusions and sketches. It would take a very long time. And here we've got an accurate, exact counterbore hole as per our dimensions. Let's move on to another example of a hex nut. So we've got our hex nut here, and we need to implement a through hole that's threaded. So let's hit H on the keyboard. In terms of placement, we'll go for a single hole. We can also define our hole type as well. So for a hex nut, we'll go simple, want that to be tapped, and we want the extents to be all. So I'm going to left click on this face. I'm going to look at that from the top view, rotate that. Okay, zoom in a bit. We want this to be in the center, right? So as we drag this around, we see the center point there. Let's snap onto that. Okay, there's no need to reference to any of the edges or the joining points. In terms of the dimensions, so we've got the hole going through all, which relates to the extents. We've got our diameter here, which we cannot edit. And the reason this is because this is a threaded hole, so a tapped hole, and we need to use the parameters down here to adjust that. So in terms of thread type, we have many different related standards. We've got the ANSIs, DINs, we've got ISOs down here. So I typically use isometric profiles. In terms of size, I'm going to leave that as 30 now, but feel free to adjust. So you can adjust that to 25. But for this particular size nut, I'm going to go with 30. Designation, so that's the pitch thread. So I'm going to leave the standard there, 3.5. Class, and then direction of thread as well. So if it's a right-hand thread or a left-hand thread. And then the final option we have here is modeled. So if I rotate the view now, we can see a visual thread in the preview. I click OK there, you see that thread is just a visual. So it's just a texture on top of this surface. It's not a physical thread. Whereas if I right click on that feature, go edit feature, if I now select modeled, you'll see the appearance changes. I click OK. We now have all these additional faces and geometries forming a physical thread within that nut. And that's absolutely fantastic if you are 3D printing. This is what you want to have, a physical thread, so that you get that when you're 3D printing. However, if you're designing many parts with many threads, I would recommend, when necessary, not to have the modeled selection ticked and just to leave them as visual threads. And the reason that is because if you have many parts with many physical threads, all those additional geometries put quite a bit of strain on your computer's graphics card and processing unit. So where possible, I would leave it unmodeled and just as a visual thread like so. If we click OK, there we have our hex nut with a visual thread. So far we've covered single hole positioning. Now let's take a look at multi-hole positioning. So let's press H on the keyboard. Then under our placement type, let's go on multi-holes. Now here we need to define sketch points. So we need exact locations for where these holes will go. I'm going to do this on this block, but currently I don't have any sketch points. But cancel on that. I'm going to create a new 2D sketch on this face here. Left click once. Go on the creation tools and we'll select points. Let's put in 2 points. I'm also going to draw in a line. I'm going to put that as a construction line. And I'm going to mirror these 2 points to the other side. We'll start at the midpoint of this vertical over to the midpoint of this vertical. Okay, press D on the keyboard for dimension. Let's dimension this one, the vertical 20, and then to the top horizontal 20. Let's use the horizontal constraint between these 2 points. Press D on the keyboard again. We'll put in a distance here of 20, then that's fully constrained. Now I can use the mirror tool. I'm going to select these 2 points here. Then under the mirror line, I'm going to select my construction line. And we can click OK. Then we can finish the sketch there. Back to the home view. And let's press H on the keyboard. Back to the hole tool. Let's go on our multi-hole placement. And here we need to define our sketch points. So I'm just going to drag around this one, this one, this one, and the last one. Look at that from the top view. Rotate that again. So that's how we use the multiple tool placement. We must have these points input in a two-dimensional sketch that we can later identify as the positioning that we want to have these holes. So as an example here, let's go over a hole type. Let's go on countersunks and hole type tab. Let's just do simple. And under the extents, let's go through all. In terms of dimensions relative to the size of this piece, let's go on 20 as the diameter of the counterbore. 90-degree counterbore, that's standard. And then the diameter of the hole, let's go for 12 mil. Let's have a look at that preview. It's looking good. And again, we can adjust any of these parameters with the 2 arrowheads here. I click OK. Now we've got our multiple holes positioned just from one feature. And again, like any feature, we can edit them by right-clicking, selecting Edit Feature, make any according changes in our toolbox there. In the last example, I just want to show you that holes can penetrate existing features. For example, I've got this cube here with a slot feature running through it. Let's press H on the keyboard. And in terms of placement, we'll go for a single hole, and we'll select this face here. And in terms of positioning, snap that onto the center there. Let's choose the extensors all, choose the hole type as simple, and let's put a thread on this one as well. Let's go an isometric profile, and for the size of this, go for 30, press OK, and there we can see we have our through hole feature there that is threaded running through an existing feature. Okay, so that is an overview of the hole tool. I hope that all makes sense. Any difficulties, please send me a message. But aside from that, I will see you in the next lecture.